Thank you everyone for coming to this second day of the ARCHER2 for program developers course. Today, so while yesterday was very much about how to get onto ARCHER2, how to run on ARCHER2, what ARCHER2 looks like, what ARCHER2 feels like, today will be a lot more hands-on as a day. So we'll start the day with a quick introduction to the debugging and profiling tools on ARCHER2. It's going to be very brief, and in fact, I doubt I'll be able to hold it in, it's been given an hour, but it might overrun a bit to an hour and a half. If that's the case, don't worry too much about it, or I hope that's okay with everyone, but if it does overrun, don't worry too much. In terms of timings, the how to be a good ARCHER2 citizen and using safe can be reduced greatly, which means we'll still be able to make the 12:15 lunch break. So we'll be able to push everything back a bit. And then after the lunch break, the aim of the afternoon session is twofold. The first one is to give you an idea of where to go next from this course, where you can find further teaching material, where you can find further help if you require it. And also, Juan and I will spend some time helping you with any specific questions or answering any specific questions that you might have related to your work rather than generally related to the course. And there's an optional practical, which you're more than welcome to do, about benchmarking molecular dynamics performance using GROMACS, which will help show how with GROMACS, which is quite a well-used molecular dynamics code, you can get different performance and better performance or worse performance if you're running with single-threaded versus multi-threaded, with pure MPI versus hybrid, OpenMP and MPI, where the peak in performance is, so how many threads you should use, that sort of thing. So just some normal performance stuff. Before I start further, I will put two links. I apologize again for the tunnel. I'll put the link to the course material into the chat, and I will also put a link into a link to the Etherpad into the chat. And now we can start proper. If you want to add anything to the Etherpad, I'm just going to do a day one. Please add it above the day one line, just so that it's easier to get to. Right. So with that, let's start with debugging and profiling. We're going to start talking about debuggers. Now, debuggers can be useful if one of your programs isn't running as you'd expect, or if it's not compiling as you'd expect. Actually, mostly not running as you'd expect. ARCHER2 has a range of debugging tools available on it, as well as a number of profiling tools. Currently, it has, for debugging, it's got GDB for HPC, which is Cray's special version of the GNU debugger. The GNU debugger is a very good debugger, open source, great for serial programming. GDB for HPC is the GNU debugger made for HPC. It loses some of the functionalities of GDB, mainly if anyone here has used GDB before, you lose the nice graphical interface that is often associated, or I say nice, you lose any graphical interface that's associated with GDB. But it does work pretty well. It's probably, of the debuggers that I'm talking about here, it's probably the easiest one to use, the most intuitive, and can tell you a lot of information if you're aware how to use it. There's also Valgrind for HPC, which is to help debug any issues with parallel memory. It helps find memory leaks and other errors in parallel applications. And it's nice insofar as it aggregates errors that are similar across processes and threads to help find what the source of the error is in parallel applications. Currently, there is not stat, and that should be deleted. So my apologies for that. That's a typo. There's also ATP, which is the abnormal terminations protocol, which is a Cray program that will let you, let's say you run something and your program crashes for whatever reason, you can rerun the same program with ATP enabled. And what that will do is you'll get some information as to why your program crashed. It can be quite useful as a nice first check of why something's crashed. And then finally, CCDB, the Cray Comparative Debugger, is a nice tool that lets you compare two versions of code side by side to analyze the differences between them. It's very similar to, I don't know if any of you use this, I tend to use Kate when I'm writing code. If you can split screen on Kate and have that sort of, how do you do that? Splitting screens. There's a screen, I think it's just Control L, is it? Control Shift L, there we go. You can split screen in Kate. It looks very similar. So part of the reason that I'm not showing you CCDB on ARCHER2 is because my internet connection is quite poor and transmitting any sort of X server thing can take a long time, and CCDB is quite expensive from an X server point of view. So I've never actually gotten it to load properly because it takes so long to load. But it is there. As with any other module, to get access to any of these, you would need to look for it. You can load the module with module load, and you can, what's the word I'm looking for? You can use module help to get some more information about, in this case, ATP, abnormal termination process. It gives you a description. It tells you the output files. It will create an ATP merge bt file, and then it'll tell you, well, if you want more information, type man ATP, and things like that. So it wasn't man ATP, was it? It was man ATP something. It should be a man ATP. No manual entry. Well, that's interesting. But yeah, so the other place as well that you can find information about all of these is the ARCHER2 documentations. There we go. If you go under the users and best practice guide, there will be a guide, or there should be a guide for debugging and profiling. Most of what we'll talk about is also covered in these guides, and actually there's probably more details here, but you could just click on ATP, and that tells you how to use ATP and more information on this. For this specific exercise, we will be mainly looking at. Sorry, I heard that there was a question. Just checking. What's going on? Ah, right. You need to load ATP first. Thanks, Juan. So that actually kind of makes sense. Load ATP, and now if I man ATP. I can now see the manual, and that tells me how ATP runs, what it does, that sort of thing. Thanks for that, Juan. So for today's part on debuggers, we will be only playing around with GDB for HPC because, well, mainly because I think it's the most useful for debugging a code line by line. And this is going to be done as an interactive exercise. So please do make sure that you're all logged into ARCHER2. And then what we're going to do is we're going to download this code. Now, because we'll be running this code on the backend nodes, one thing that we'll need to do first before doing anything else is go into our work directory, because we can't launch from our home directory, as we found out yesterday. Or we can, but nothing runs. I'm just going to make a new directory, debuggers. There we go. And I'm going to get that code. You can just copy and paste from the exercises. And if anyone wants, I will also copy the GDB for HPC exercise into, let me see. I will copy it into /work/TA022/shared, which means that anyone can get it from that directory on ARCHER2 if you'd rather do that. Great. So we've got a code. I'm going to very briefly look at it because this code is very, very buggy, but the bugs are kind of obvious. I'm mainly using it to show a point. I'm pretty sure you could tell me where the code's going to go wrong just by inspection. But let's not take too long about it. This code, what does it seem to want to do? Well, it seems to want to set up, it seems to want to run on a couple of processors. It can run on more than a couple of processors, I suppose. And it's going to set up some communication between the two processors, and then it's going to try to sum up all of, it looks like it's trying to sum up all of the even numbers between 0 and 20, and then print what that value is. And then there's a little function there which does some things. Great. So let's compile this code to run it through GDB for HPC. So because we're wanting to, well, this is a C program, so we are going to use the C wrappers. We want to debug it. So we're going to need the debugging flag -G. And then it's the program, and let's output it to, I don't know, let's call it test GDB for my program. There we go. It compiles happily, and how busy is ARCHER2 at the moment? It's not too bad. So I can srun partition equals standard, QoS equals short, reservation equals short QoS, time equals 0. It's going to take less than a minute. 0, and then just test GDB. That should be enough for it to run. And then it doesn't run. There's an issue. I get an error, and the job just crashes with a lovely core dump. Yay! Let's remove that. Cool. So we now have a lovely compiled buggy bit of code. What do we do now? Well, as I said, we'll be using GDB for HPC. So first thing we need to do is load GDB for HPC, and then start running GDB for HPC. So one thing that you might notice is with GDB for HPC, it comes with a version of normal GDB, of serial GDB, as well as the for HPC version. Because this code is in parallel, I'll be using the for HPC version, but if you've got some serial code that you're also wanting to debug, you can totally use this module as well. So you load this up, and there's a number of lines telling you, well, you're using Cray Comparative GDB for HPC version 4.8, which is built by Cray, some copyright information, and then it tells you type help for a list of commands. And if you want to find out more about a specific command, you'll need to type help command. So if I type help, it indeed lists all of the commands that I can use. We won't be going into all of these. We'll be going into just a couple of these. And then if there's a specific command that I'm particularly interested, like say let's say I'm interested in what the stop command does, I can just do help stop. And then it tells me, well, stop is the way I use it. Well, summary, what does it do? It halts it's the assertion script halt command. To use it, you just type stop. Here's an example of using it. It needs no arguments, and it halts it stops whatever is currently going on. When you're in the GDB debugger, normal shell script doesn't really work, so I couldn't do something like clear, for instance, to clear my screen, because it's not one of the commands that the debugger understands, the list being here. So we're in the debugger, and we now want to debug the terribly written bit of code that we're all hopefully looking at. So how do we do this? Well, the way that the debugger works is it will let you launch your code just like in a very similar fashion to, I think it's quit rather than exit, isn't it? Yeah. In a very similar fashion to when I just ran with srun. It will let you run your code on a backend node, but you need to be careful about some of the, what's the word I'm looking for? You need to, there's a different way that you need to input the commands. So what do I mean by that? Well, if we look at help again, one of the commands that we get is launch. And if we look at help launch, that tells you what launch does. And launch does, there's a lot of information about launch because launch is kind of important. And it tells you, well, roughly speaking, launch will launch an application. And we're wanting to launch our buggy code to the backend nodes so that we can go through it step by step with the debugger and find out where the issues arise. So to do this, we'd want to run launch and then the name of our code. However, there's some issues with this, which are that, well, as we saw yesterday, let's restart. There's some issues with this, which is that launch is set up to launch something as an srun job. So it does exactly the same thing as srun, just through the debugger as opposed to through srun. And as we saw yesterday, if you're wanting to launch an srun job, or if you want to launch something to the compute nodes, there's a certain number, there's a minimum number of fields you need to specify for it to even launch. So the way you add those fields is by using the launcher arguments. And annoyingly, you need to enter them much like before. So the launcher arguments here would be partition equals standard, QoS equals short, reservation equals short QoS. And because the short queue has a maximum runtime of 20 minutes, I'll need to also say that the time I want to run is, I don't know, call it 5 minutes. For now, just because of how quickly it'll crash, I'll call it 10 actually. We can do 10. Yeah, that's another issue, is if I press arrows, it's not happy. Launcher args equals, apologies for this. Partition equals standard. QoS equals short QoS. Reservation equals, that should be short QoS. The QoS should be short. And finally, we wanted time equals 0, 10, 0. Okay, cool. So that gives, that will tell launch, launch, I want you to do an srun job, and I want that srun job to have all of these flags associated with it. Then the next bit we want to do is we want to give our dummy program, the thing that will be going through in the debugger, a name, in which case, let's say, let's call it A, or even test run, or whatever you want. This is a dummy name. And then we want to give it the number of the number of cores we want to run it in. So let's start by doing 1. Cool. And then finally, we need to give the executable that we're doing, which in this case is test GDB. We do this, and then it will start the application, create a communication network. This can take a couple of seconds. One quick thing as well, there we go, that's already done. One quick thing to bear in mind, by the way, which I've not mentioned, you could run on partition standard, QoS standard, and use the course reservation. If anyone wants the course reservation, it's in the Etherpad. Today's course reservation is TA 022159. I will copy that into the chat. Apologies for the tunnel, everyone. There we go. Yeah. And while that happened, what's the word I'm looking for? The application launched, and you'll see that it started the application, finalized setup, launch is complete, and then it says initial breakpoint, main at, and then name of the file. So it gives you the exact location, so /work/TA22, TA22, TA22JS, debuggers, and then it tells you you're running this code, apologies, you're running this code, GDB for HPC exercise, and it tells you that the initial breakpoint is at line 9 of the code. At this point, I can do a help command to remind myself what the various things are, but The one I'm interested in, I can never remember if it's list. Yeah, I think it's list. If I run list, it shows me, well, what does it do? It shows me lines 9 through to the 18. It shows me the next 10 lines. And it shows me, I've been told that the initial breakpoint is at line 9. It starts me at line 9. If I were to run list again, it would show me the next 10 lines. So I'll just show you this. It's showing me 19 to 28. And if I were to do list again, it shows me slowly going down through the entire code until the point where it's run out of lines to show at list. So then, but still at the moment, as far as the code is concerned, we are still on line 9. The code is still on MPI init, and everything is fine at the moment. So the next thing we can do is we can do one of two things. We can do next, or we can do step. They are the two ways to go through a code. Step will, what's the word? Step is slightly better for if you want to see the full insides of a code. It will go into subroutines, it will go into functions, and it will do step by step, whereas next will just move the code forward to the next function call. So if I were to do step, for instance, it now tells me you are at line 13. And I believe if I do list, it'll list from line 13 the next 10 lines. So that's a nice way of going back. Line 13 is MPI com. Which you'll notice from all the way up here. Well, it skipped the defining of rank and just goes to there. And if I do again step, it should take me to line 17, if I recall correctly. Oh, 15. So it does do the, oh yes, because I'm defining that count is equal to rank plus 1. And I can even set some variables. So I can print, for instance, I think it's print count. And at the moment, count doesn't have a value because we're just at the start of that line. But if I run a step and then print count again, now count is 1 because count is equal to rank plus 1. There's only one processor on which this is being run, which means that for the only processor we're using, that processor has rank 0, which means that it has count of 1. We can keep stepping. And then at this point, we sort of get to this MPI send. Let's keep stepping. And now the program crashes. And the program crashes because, well, if we look, there's an else if receive, and no one is receiving. There's no processor there to receive the message that we've set. So, okay, that tells us error number 1, we need to run this on multiple processors. There we go. Just to speed things up a bit, I'm going to do the same thing and just increase the number of processors to 2. You can use up arrows and down arrows to go to previous, well, you can use up arrows to return to previous statements that you've done. Let's launch it with 2 processors. It's going to take a couple of seconds to launch. By the way, if you feel that I'm going a bit too quickly with this sort of thing, everything is in the, like everything that I'm saying is in the course material, or should be in the course material. Yep, and we've talked about help, we've talked about list, we've talked about step, not done next yet, but we can do that in a sec. Up, we've not done either, and print variable, watch variable, we're about to do. Cool, it's now run. It's happily on 2 processors. Well, let's list. That's not happening. That's not what should happen. Why are you unhappy? Step. Might need to restart this in a sec. Sorry about that. Let me just log back in. Yep, was the right password. And I noticed something's happened right before I logged in to here. seems to be unhappy, so I'll actually just restart it. That's why I hadn't filled application A when running A2, so it didn't know what it was doing. That's entirely my fault. My apologies. If I were to run sq-u$user here, you'll see that at the moment, this is just another, what's the word I'm looking for? This is just me running, logged into ARCHER2 from onto the same account, just from a different terminal. It's a different login session. You'll notice that I have something that's running, that's been running for about 2 minutes. This is the srun command that I've been talking about and launching through the debugger. So let's just cancel that. That'll probably save all of my problems. And that's just really unhappy. So I'm gonna hide this and do the same thing from a different terminal. As you can see, for anyone who has used GDB before, GDB for HPC is more temperamental. Let's remove that core and load GDB for HPC. GDB for HPC. Cool. Doesn't do previous commands, so I'll need to rewrite everything. I want it on 2 cores, and I want test GDB for HPC. Starts the application. This is going to take a couple of seconds like before. This is still doing horribly unhappy things. Yeah. Sorry about this, everyone. So there we go. So one thing to note as well is, whereas before we only had one of those number of debuggers reserved, now we've got 3. Just some small thing to note. And now if I do list, hey, look at that, it's happy again. We saw that when using the step function, it always led us to the next operation. So not the next definite, it would skip comments and it would skip definition of variables. However, it would go from MPI init to MPI comRank, and then it would also go to count rank. What happens if we use next instead? Next should move us to MPI comRank. And indeed it does. We've moved to line 13. But if I were to do next again, hopefully it should send me to around here. So let's check that. Nope, apparently not. In case that's me being entirely wrong. So if I were to now print the variable, in this case print count, actually I can print rank. Let's start by printing rank. I get an output for each processor that's being used. So I can see processor 0 has a rank of 0, and processor 1 has a rank of 1, because that's how they've been set. The cool thing that I can do is I can print other variables, and if they're the same across processors, like say count at the moment hasn't been defined, it tells me that processors 0 and 1 both have count as this random set of integers. Now, the next cool trick is you can watch a variable. You can tell the debugger, I want you to tell me what that variable is going to be like in a sec. So I can watch count to see how it changes as we go through the code. And you'll notice that count should, in a second, change. So if I now do step, it steps, and it tells me watch point 1, variable expression count, there's been a change. So that tells me there's been a change in count. So if I now print count, you'll see that count is now 1 for processor 0 and 2 for processor 1. If I run step again, I get told that processor 1 is now on line 18, whereas processor 0, core 0 is on line 18, whereas core 1 is on line 21. Well, why is that? It's because if you look at line 17, 17 is if rank equals 0. So if you are the 0th core, you go into this bit, whereas for the number 1, you go into this bit. Now, I heard there was a ping. I'll just check if there was a question. Oops, sorry about the tunnel. Oh yeah, someone's getting an error. That's a very interesting error. I'm not sure why you're getting that. Yep, that is a very good question actually from, are you sure that you're running from work? But Juan seems to be on the case during that question, so I'll keep going. Yep. Yes, it should definitely be in work. Cool. So it tells us where different processors are at different time as used through the code. And if I were to step again, that tells me that processor 0 has happily finished its sting and is now on line 19. Line 19 is an MPI barrier. And then if I do step, the application is running and unable to step through. So that's telling me something. Well, that's telling me that processor 0 has managed to finish one of its tasks and is now at an MPI barrier waiting for processor 1 to finish something. But processor 1 hasn't finished its task. So if I look at that bit of code, I can see, well, actually what's ended up happening is that I am sending something to 1 from 0, but processor 1 is looking to receive from processor 1 rather than processor 0. So there's an issue in the MPI receive command. And indeed, if you, what's the word I'm looking for? If you look, the exercise is what happens, the solution is the program is, well, no, sorry, we're actually past that point. We're at this point. Processor 1 is stuck on an MPI receive because the target is 1 when it should be 0. So we now know where bug number 1 of the code is. So we can quit and now find ourselves here, and we can open our GDB for HPC and change it. I always get these wrong. I think it should be source is processor 1, so that should be a 0, 1, I believe. And now I can relaunch GDB for HPC, write all of my launch arguments as before.
I think you need to compile first. Or
oh, that's a very good point. We'll remember it. CC -G GDB for HPC -O test. There we go. Well remembered, Juan. Clearly more on the ball than I am this morning, and I'm just going to be lazy and do this. There we go. That's going to launch. Meanwhile, I'll check real quick on the question to see if I can at all help. Oh, cool. Yeah. Cool, that's launched. It's now happy. And if I step, actually I can just do next to go a bit faster. They're now both at line 15. Next. They're now split. And this is the point where it stopped working, where, what was it? Yeah, so now it's showing me for both processors. This is the point where processor 0 was on line 18, processor 1 was on line 21, but then 0 moved to 19, but 1 didn't. So hopefully if I step, so I changed the wrong ones. I always get my MPI wrongs. Actually, let's step again just to make sure. Yeah, so I got the wrong ones. never remember. I think it's 10, probably. Might be 0, to be honest. I will actually just quickly MPI receive. Count in source in tag. Yeah, that's what it is. Cool. MPI. Yeah. So CC GDB for HPC. That's not what I wanted. Copy that. There we go, run that, and hopefully it'll run at this point. Here we go. They're both split, and now if I step, one of them moves. If I step again, nope. Okay, cool. Sorry about this. This is entirely down to me failing to MPI live.
Yeah, I think the tag is the same is 0, so that's fine. So send should be you should send to processor 1
Oh,
and you receive from processor 0.
Right, so it should be 0, 1, 0, 0, 0. Yeah, that makes sense. Thanks, Juan. You're clearly
No
much more
worries,
awake than I am this morning.
for me it's also difficult to remember the order of the commands. Sorry, the parameters.
I'm sorry, everyone, for getting this terribly wrong multiple times. This is the bit where it failed, and now if I step, they've now both moved on, and if I press list, we have overcome this first problem. Thank you very much, Juan, for spotting my mistake. So one of the processors is now at line 23, whereas the other processor is at line, one of them's at line 23, whereas the other one is at line 19. So that's why you have the output from line 19 to 18 and then from 23 to 32. It's showing you for each processor where they are and what the next 10 commands they see are. If I step, they both end up on 20 and 27. So why is that? Let's have a look. On 20, the processor 0 has reached the else if, which it's just going to jump over, and processor 1 is about to just jump over this entire thing. So if I step, processor 1 has jumped to the MPI finalize and will stay there until the end of the run, whereas processor 0 is at 27, so is getting to that point. If I step, it's in 28, so initializing some even. And if I do list, it's showing that, step. And now processor 0 has jumped to line 43, which is the definition of the sum even function. Now I'm going to watch variable result, because that seems to be the important one, and just keep stepping. And you'll see result has changed, so let's print result. Seems I'm happy to, and if I step, there seems to be something weird happening. So it's gone to 26, 27, print result. Maybe I need to specify processor 0. Nope. No symbol result, and it's telling you for processor 1, it's just, oh, that's because I'm doing results rather than result. Processor 1 is not printing anything. So there's clearly something going wrong in that loop because it's just going over and over and over in a long loop. So there's something happening in that, what's it called, in that SUMEven function. And if you look at the way that SUMEven is written, you'll notice that the while I is less than or equal to max, there's this if loop, which means that it's all the result is never updated, and that's why when printing result, it was never updated. And the I++ is inside the if loop, whereas it should be outside of the if loop. And if I were to change that, hopefully the code would now work fine. There's, I think, a couple of things still wrong with the code, which for the sake of time, I'm going to leave as an exercise for you to do offline or during the practical session at the end of the day, just so that I can speak a bit as well about profilers. But needless to say, as I mentioned before, GDB for HPC is a really good debugger, even though it has many quirks and can sometimes be difficult to get a hang of. It is very good for multiple processors. And you'll notice at the moment I've only did a small test case where the job is run on 2 processors. It can give information for jobs that are run on 4 nodes worth of processors, 4 nodes worth of cores. So it's really powerful and can give a lot of information. I'm just skipping the last bit of the SUMEven, and if you look at it, the solution to the code is the I++ should be outside of the if loop. Cool. So profiling. ARCHER2 has a number of different profiling tools. Sorry, before I carry on, actually, just to make sure, are there any questions about debuggers that you'd like me to answer? I'm more than happy to answer questions about debuggers. Because I realized that I went through this very quickly and that there's a lot of information there. Everything clear? Wow, cool. In which case, I'm happy to keep going with profiling tools. So profiling tools are useful for getting an idea of what your code is doing. They can tell you how much time your code is spending in certain functions, how much time it's being spent in serial versus parallel functions. They help you know which part of your code you need to target to performance and things like that. ARCHER2 has a number of profiling tools. There is Cray, which is it's a programming analysis tool developed by Cray, which consists of a number of major components, including pat build, which allows you to build your program in such a way that it'll output a lot of performance information. There's the Cray runtime environment, which is very similar to the GDB for HPC runtime environment, if I recall correctly, which collects specified performance data and during the execution of a program. And then the pat reports are, it's a tool for generating reports to tell you what your code was doing, how long it was spending in various parts of your code. There's also a Cray Lite, which is a much more simple and more easy to use version of Cray that gives you a lot of performance information, but is a lot more easy, takes a lot less effort to use. It doesn't necessarily give you all of the information or have all of the functionalities that Cray has, but it tells you, you can often get 70, 80% of what Cray would give you for, I don't know, 20% of the work for a lot less work. So Cray is usually the first go-to for profiling. Then there's Reveal, which is the next generation integrated performance analysis and code optimization tool that helps you correlate performance data capturing program execution. I will admit I've not really ever used Reveal, but I'm pretty sure that if I were to, no, that's the wrong window, my apologies. if I were to go on the ARCHER2 documentations and go in best practice guides profiling rather than debugging, it tells me about CrayPath Lite, tells me about CrayPath, but it doesn't really talk about reveal, so there might be currently a problem with reveal. I can check that actually, because module avail reveal, yeah, it doesn't seem to be available just now. Is that, yeah. But then there's also PAPI, which are support packages if you want to access performance counters. And then there's the Cray Apprentice2, which is a second level data analysis tool, which helps you visualize, manipulate, and compare the performance data that you've obtained using CrayPath, CrayPath Lite in a non-visual graphical user interface. Yeah, so for the next 30 to 40 minutes, I will be showing you how to use CrayPath and CrayPath Lite, starting with CrayPath Lite. The first thing we'll do is download. Are you still horribly unhappy? You're horribly unhappy. I'm just going to close this. There we go. What was I going to say? Yeah, so starting with the usual let's get something from online. When I say let's get something from online, those of you who are observant will notice that this links to the course webpage. And so don't worry about it. This is actually just a link to part of the course webpage. And I will copy this again to the /work/TA022/shared. So that if you don't want to use the wget command, you can just copy it from there. So then we need to extract the items. So extracting, verbose, it's a file, and that's the file I want to extract. And when I extract it, I get a new directory called nbody_par. And if I go into nbody_par, I have a number of files. So there's a main.c file, there's a make file, there's a couple of header files, there's a couple of other, what are the words, other function files. And then there's also a run.slurm, which hopefully should be made such that it has the correct account number. It should be running on short queue and reservation short QoS, though as always, you're welcome to use standard QoS and the reservation number for this course. And it's got just everything that we saw yesterday. So it's asking for times, a certain number of nodes, a certain number of tasks per node, CPUs per task. Note that it is underpopulating the node. It's asking for 64 cores, as opposed to the 128 that are available. And no multi-thread, which we talked about yesterday, and then distribution block. And then what it does is it runs words fail me. It runs an executable, which we've not yet generated. So if we look at the makefile, the makefile tells you that it requires the CC compilers. It's got MTI added. There's no optimize and no debug at the moment. And then it just tells you what the debuggers, you just add the G flag and things like that. It's a makefile. So let's load our perf tools Lite, and I'll just show you actually what the module does first. Is it perf tools Lite? Sorry, apologies. It shouldn't, yeah. Veil perf tools. There we go. Yeah, there it is, perf tools Lite. So module show or help even. Perf tools Lite, and that tells me this instrumentation enables CrayPath Lite. So that's why we're loading PerfTools Lite rather than CrayPath Lite. It's because CrayPath Lite is part of the PerfTools Lite package. I'm pretty sure if I do a module avail CrayPath like that, there's nothing there. It's on ARCHER2 as part of the PerfTool and PerfTools Lite module as opposed to the CrayPath and CrayPath Lite module. So that's why we're loading that instead of CrayPath. Cool. So we need to load PerfTools Lite before we compile our program. And then, if I recall correctly, we can just make the program. So let's run make. And you'll notice that the final line in make says creating the PerfTools instrumented executable nbody parallel.exe. If I run ls-lrt, you'll notice that there's now a bunch of .o files as well as two executables. There's parallel.exe and parallel.exe plus origin. If I were to run make clean, for instance, and then do ls-lrt, this remains, which I can just get rid of parallel. And if I were to, this is just to emphasize a point, you don't need to do these steps, but if I were to get rid of PerfTools and then make again, I do not get the line saying you're using PerfTools Lite, and I also do not get the nbody parallel .exe plus origin, the one that I had to get rid of manually. So you need PerfTools there, or you're not. You need PerfTools loaded before compilation, or you're not going to get the advantages of PerfTools. Cool. At this point, we can simply run the run.slurm, and that will run the executable that we built, and it will hopefully output the PerfTools data, or the CrayPath Lite data. It's currently running. It doesn't take too long to run. And now I have a number of files that have been generated. So there's the data nbody parallel, which is the output from, it's the output from the program. I can't quite remember what the nbody program does. It probably says in main, actually. It does not say in main. Cool. But yeah, I can't quite remember off the top of my head what it does. So apologies for that. But on top of that, we get the slurm out file, which we've seen before, and it looks so far so good. And then that's the output that we expect from the nbody command. But then after that, we get the CrayPath Lite performance statistics. And it tells us things like, well, the number of parallel environments, there were 64 cores. Parallel environments per node, there were 64 cores. Threads per parallel environment, there was only one thread. So that's all fine. And then it tells us average process time is 0.77 seconds, high memory, I/O rate. And then there's also some handy tables that tell us, well, a profile of the function. So how much time was spent in various places. In total, there was 100% of the time that was spent there, 77% of which was in user, 77% of the user, 77% of it was spent in user, and the whole of that was spent in compute forces multiset. Then it also tells us, well, so 77% was spent in serial, calculating this, but then 20.9% was spent doing MPI calls, 15% of the time was spent in opening files using MPI, 3% was spent in sending and receiving things, and 1.5% was spent in MPI writing things. And then finally, there's a last tiny bit of the code which is spent calculating the square root of something. So already quite a lot of information. We can see exactly which functions are taking the most. So you can see that the user-defined compute force multi-set function is the one that's taking 77% of the time, which is a large chunk of the programming compute time. Then this tells us table 2 is an even more in-depth breakdown. So now we've got an overview. We know that compute forces multiset takes most of the time. This breaks it down even further. It tells us that of all that time, most of it was spent on line 148. And we can find out which one, it tells us this is parallel.c. We can find out exactly what line 148 did by looking at the code, but it tells us, yeah, about 25% of the total runtime was spent on just this line. So maybe that's something we'd want to look at. But also 149 and 150 took a while as well. Then the MPI functions, they were already divided as much as necessary, likewise the square root function. Then we can get information about memory bandwidth, how much time was spent on sending memory, on reading memory, on writing memory, what the traffic was like in gigabytes per second, et cetera, et cetera, et cetera. There's total power usage. I'm not too sure how accurate that is. That would be really cool if that was accurate, but I know that measuring power, depending on how CrayPat measures power, I wouldn't necessarily trust the power usage. Like, I know that this is something that we spent some time thinking about. And then here you're told, yeah, the output stats. So what was the write time? How long was spent writing? That sort of thing. You get loads and loads of really detailed information, even though, what did I do? I loaded up CrayPat and compiled something and ran it. So yeah, CrayPat Lite, fantastic, tiny amount of work. You get tons of details from it. So that's CrayPat Lite, and as you saw, it's super easy to use and very, very informative. The other thing we can use instead is use regular CrayPat. So unfortunately, you can't have both CrayPat, or you can't have PerfTools Lite and PerfTools loaded at the same time. So you'll need to unload PerfTools Lite and load PerfTools. Sorry. There we go. I'm just going to remove.
Just to make a quick comment about Cray reveal, that tool is including that module. We will update the documentation to reflect that, but this is like is a tool inside that. Yes, since that is like separated, but it's inside that module.
Okay, cool. Thank you very much. So indeed, if I were to do module help PerfTools. That tells me it has CrayPat. It doesn't tell me about reveal either. Cool. Maybe we'll mention that to Cray as well at some point. But yeah, sorry about not having more information about reveal, everyone. Cool, so we've made clean. We've loaded PerfTools. So now if we make again with the full PerfTools version, you'll notice that this time there is no information telling you, oh, you've built this using CrayPat. That's because with CrayPat proper, you need to take your application that's been built, you need to take the binary that's been built, and you need to use pat build to generate a performance, an executable that will tell you the performance information that you're after. So pat build, and then it's nbody parallel.exe. There we go. And if I do ls minus lrt, I now have a new executable called nbody parallel.exe plus pat to tell me it's been built, pat build. Cool. So same as before, I can just, in the run.slurm file, I'll change the executable name because the executable name is no longer called nbody parallel.exe. It's called nbody parallel.exe plus path. And now I can just run this. And it's already running, which means that this is great. It'll finish really soon. This is, by the way, a pro tip, everyone. Monday mornings before 11 is time. Like, there's no one on it. You can get anything launched. It runs super quickly, and usually actually mornings are the best time to launch things as well, because people tend to launch more in the afternoon than in the morning. Cool.
Just one comment, because the break is from 11 to 11:15. Do you want to continue or have now the break? If would you mind saying that in the chat?
Yeah, I'm happy to ask in the chat. I think I mentioned.
Sorry.
I think I mentioned at the start of the session that this was likely to overrun until 11:30, and that we could have.
Oh, sorry, sorry, I missed that.
It's okay. I'm happy to take a poll to see if you'd rather we take a break now. Like, if you'd rather we take a 15-minute break now and then finish with profiling after the break, or we can take a break after the profiling. So I've got 2 happy to continues at the moment. So cool. That's 3. So I will continue with profiling, and then we'll have a break at 11:30. And I think, Juan, please tell me if you disagree, but I'm pretty certain that we should be able to do the ARCHER2 citizen and using safe in less time than they've been scheduled for. Do you agree, Juan?
Yes, sorry, I missed your previous comment about that they will take longer, this part. So yeah, no problem at all. We can.
Cool.
Yes, sure.
Awesome. So where was I? Yeah. So if I run ls-l, what have we got? Well, we've got a number of things that have been output. First of all, there's this nbody parallel .exe plus path plus this is, I believe, the I think this is the process number, and I can't quite remember what that number is. There's the data that's been output, and there is also the slurm.out text. If I look at the slurm out, this does not include all of the lovely information that we got when we were using the CrayPat Lite version. Part of the reason for this is because we're now using CrayPat, and CrayPat looks more for, what's the word I'm looking for? You need to instruct CrayPat about what you're interested in looking at, whereas CrayPat Lite will give you a brief overview of generally everything. You're probably getting from the way I'm describing these that I'm much more of a fan of CrayPat Lite than I am of CrayPat, but still, we'll talk about both. Yeah, so there's the only new thing that wasn't there before is this, and this is a directory. Nbody parallel.exe plus path plus, there we go. It's a directory, and inside there's xf files. So how is the directory name chosen? You've got exe because that's the name of the executable. Then you've got plus path because it's been compiled with path. Then you've got process ID, the ID assigned to whatever the job number was. Then you've got, apparently that's the node number. There we go. So this job ran on node 1016. And then finally, the S at the end tells you that we were sampling rather than tracing. And you can set CrayPat to trace rather than sample by setting, I believe it's a flag somewhere. I can't remember where the flag is, unfortunately. So once we've got this sampling report, we can use pat reports to get information from it. We can generate a full report by running pat report, and then the name of the directory, which is nbody parallel plus plus. And if we just run this, we get a ton of information printed to screen. a ton of information printed to screen. I'm actually going to send this to a report.dat and then vi report.dat. It gives you, well, the starting information is very similar to Cray Patlite, but it does go in a lot more depth. So this information is, again, very similar. You'll notice that this time it took 87% of the time rather than 77. Just got unlucky or lucky the first time, I'm not too sure. Here, for table 2, where it goes into each function to tell you a bit more about it, it does take the time to break down even the MPI functions, which Cray Patlite didn't bother with. Cray Patlite went, MPI is a non-user defined function, so the user is unlikely to be fiddling with it, which means let's not worry too much about the ins and outs of this. CrayPat does not do that. CrayPat will check everything and tell you about everything. This is, again, very similar to before. Line 148 is taking the biggest chunk of the time, followed by 149 and 150. We can even look at what those are if we wanted. And then here we get lots of information about hardware performance in this case. So you can find exact hardware performance for your run. You can find the output stats like before, luster file informations like before, energy usage, NUMA nodes, which NUMA regions did the more work versus which ones did the least work. They should not be even because I was only using the processors on I was using the cores on only one processor, and the way that the run .slurm file is written, you'll be using the cores on a single processor rather than across both processors, which means that NUMA regions should not be using the same amount of time. But NUMA region 0 is using way more than any other NUMA region, presumably because that's where the lead processor, the lead core is. And it's actually telling you in each NUMA region which processor is doing most of the work. Memory bandwidth we like before, wall clock time, and then there's loads of other additional details. Yeah, there is loads here. You can find out all of the information and then some about any job that you run using CrayPat report. Now, the other cool thing about CrayPat reports is that you can ask for specific reports. Let's see, for instance, if you're interested in profiling by groups, functions, and lines, you can use certain flags, and I think actually I skipped that one, yeah. Here, if you want to only look at profile by function, you can use flags like -b, -o, which will give you just function information. And if I were to just go up there and do pat report -v, -v, -o, I'm trying to think what it is. There we go. Why are you unhappy? Sorry, one. Oh, it's because I'm doing sample profile. Yeah, cool. Patch report. So I want a sample profile. You just name the profile whatever you want. Why are you unhappy? I'll just copy this. It'll probably be better. I think I know what I did wrong. I put the -v, -o on the wrong side. There we go. What? Sorry. Apologies for this. Yeah, that's me being a silly. There we go. Finally, after only many attempts. And I put this to report just so that we can read more easily. There we go. What does that do? That gives us a much reduced report from CrayPat, which tells us about the functions as groups, and then doesn't give us any of the other information. So we don't have anything about, I don't know, we don't have anything about power usage, we don't have anything about bandwidth, we don't have anything about, what were some of the other things we had? We don't have anything about the breakdown of each of each function or anything like that. We just get the very basic, here's functions. And pat report, I think if we do this, or help pat report, nope. Oh, there we go, info pat report. If we run this, well, we can see all of the options that we can use for pat report. And it'll tell us, so for instance, -O, use the -H option to help help content specific to the report. And -V is going to be verbose, presumably, because -V is always verbose. And it sort of tells you all of the things you can ask for. So what we had was SAMP profile. And if I can spell, there, it tells us what SAMP profile does. It tells us, it shows a sample data line by line with by line with each function, which is what we got. So there's other things you can do with the pat report as well. You can output, if you were interested in groups, functions, and lines, you could use SAMP profile plus SRC as opposed to SAMP profile. Plus SRC. And then if we look at the report now, it tells us not only the functions, but also the line data, because that's what we asked for it. In this case, it doesn't tell us anything about the MPI. Line data, and then the additional details is just additional information. You can find out information about, if you want to profile functions with callers and line numbers, so who called the function, what line number were they called at, that sort of thing, you can use CA plus SRC. CA plus SRC. And if you look at the report, there we go. What does it tell us? Loads of notes for table 1. And then table 1 tells us, well, compute force multi, run parallel .c, it's in line 81. And then in main, it's called from line 81. And hopefully, if we were to look at main.c and go to 81, that's not 81. That's 81. That's an MPI finalize. That's not where it should be called. So that's me being wrong. Apologies. I'm looking at parallel. Yeah. And if I go to 81, there we go. That's probably the line where it's being called. Probably. I might be wrong, actually, in this case. Oh, no, there it is. It's being called in 79. Why is it saying 81? That's weird. But yeah, so you can find a bit more information about that. And there are a number of other different ways that you can use perf tools to get more and more information. So all of these reports generate a couple of other files which we've not really talked about, but if you remember when I did ls nbody parallel plus, there we go. There was only one file which was called xf files, and if I now do run ls, I get xf files, but there's now a number of things that have been done, such as files, build options.apa, and index.ap2. So let's actually go into this. And if you ls star, you'll notice that, ap2 files is a directory, and xf files is a directory as well. Now you can use these things that are built by what's the word I'm looking for? Yeah, so the reports generate a number of other files, but in preprocessed form. And the other one is called buildoptions.apa. And this text file suggests configurations for generating a traced experiment so that you can build a traced version of your program as opposed to a sampled version of your program. You can look at this file. So vi build options, and it'll tell you, well, maybe you want to use this. And it just gives you ideas for flags that you might want to use. And one of the cool things that you can do is you can build using pat build by taking those options into account. And the way you do that is just pat build -o, and then nbody parallel plus plus build.apa. And this will create a third binary, which is called nbody parallel exe plus apa, which you can then run as before and generate a pat report for it and have a look at the things that are done. So I'm more than happy to do this. .slurm apa sbatch run su-u user. It's already running. It's probably already finished. And then I can ls-lrt. You'll see that I now have a brand new directory, which is called exe plus apa. I'll just copy this, and then I can pat report. I think just type that, and let's send that to report. And that will tell me a breakdown of the new file that's been used, much like before. But that's sort of a way of iteratively getting your code to hopefully perform better and better and better. So the other thing as well is that these tables here, tables are all generated using tracing data rather than sample data. So as opposed to CrayPat every so often going, okay, what are you up to? So I guess I've not defined that. The way that CrayPat works when you're using a sampling versus a tracing is every so often it will ask the program, what are you up to now? And it'll say, oh, you're doing this, I'll take it in this box. And that's how it performs that's how you get the profile. So that can lead to some inaccuracies. The tracing version of the program, the reason that you might be interested in getting a trace rather than a sample, is that it will follow what the program is doing and lead to a much more accurate breakdown of what your program is up to. And this is how you can generate that. Cool. I think so. So like before, you're able to get information. You can pat report. The best way to get that information is most likely to use the info command that we talked about, info pat report, which also gives you a list of all of the pat reports that you can ask for specifically, and gives a brief description of what all of them does. We've not looked at too many of them because there's loads of them, but you can even look at like how, load balancing. You can look at loop times. You can look at, there's loads of things to do that you can use CrayPat to check, to really profile your program and get as much information as you can out of it. So at this point, I think that's most of the profiling lecture finished. The final thing I've already mentioned, if you're interested in finding out more about debugging and profiling, the best place to look at as a starter is the ARCHER2 user documentation, where we've got a lovely guide on how to use all of the debuggers and profilers that I've talked about. And if you still have any further questions, or if the questions that you're after aren't answered, you're more than welcome to send us an email at the ARCHER2 service desk at support@archer2.ac.uk. And with that, that's the end of the debugging and profiling tools part of the course. If there are any questions, I'm happy to answer them. I realize there's a lot of information that was said here. So Ruben, the error that you're getting is because did you run srun in shell? As in, did you run it straight from bash, or did you run the batch submission script? If you ran it in bash, you'll need to specify, to get srun to run, you will need to have srun minus minus, I'll move this up a bit so you can see, partition equals, there's only one partition, minus minus QoS equals either short or standard. Let's say short. If you're using short, you'll need to specify as well a reservation, which is short QoS, and you'll need to specify a time, which is less than 20 minutes. And only then, if you've got those things, are you able to launch something. So like, for instance, now I've just launched a shell script. Yeah, no worries. Please let me know if there's any questions about profiling and debugging. I realized that that was a lot to take in not very much time, but I'm more than happy to answer any questions you might have. I guess, again, for me, the takeaway message is CrayPat Lite gives you loads of information for almost free, so it's almost always worth trying out as the first port of call, and then only if you want some more detailed, in-depth information would I go move on to CrayPat regarding profiling. And then Debuggers, GDB for HPC is probably the best one available on ARCHER2, but it's still a bit tricky and temperamental to use.
Okay, so what we will see now is we will try to because I mean in the afternoon I would like to give you the opportunity to test ARCHER2, to do the exercises and get us and also give you the opportunity to ask as many questions as you have. So what I will do is I will try to cover these two, actually the next two lessons that we will see, that is how to be a good ARCHER2 citizen and using safe. That one, the using safe, we have already seen most of it, so it will be like shorter than half an hour. So we'll try to keep the lunch break at 12:15. Well, we'll see. Let's start and see how it goes. Okay, so yes, the idea of this lesson, how to be a good ARCHER2 citizen, is to give you some hints or some advice in order to use ARCHER2 in the most fair way, in order to because ARCHER2 is a machine that is shared and is used by a lot of users, and I think is if all of us make a good use of Archer, all of us will be happy in the. So let's start with that. That is about the login nodes. Login nodes are a shared resource. And for example, if login nodes are aimed to compile smaller programs, or to do quick testing, to copy paste, to do like small stuff, to run jobs, you need to use the compute nodes. Because otherwise the login node, the performance will be bad, and will be not the best. If for example, if a user runs a heavy job that consumes a lot of CPU resources, another user could find that and could see the performance to do usual stuff like quite deteriorated. So what we have here is some okay, like a small exercise called login node etiquette, So we have 5 commands, or yes, 5 commands. Would you mind to think about them just a couple of minutes and see if these commands make sense to run them on the login node or Archer2 or not? Please, when you're done with the exercise, let me know, typing done in the chat. Thanks. So let's. I see that yes. Let's solve this together and discuss the answers. So first one is Python, Python, and then a file, a Python script. So for example, this one is likely not okay because it seems that the software that will run is a simulation of a test case related to physics. So it's more likely that we will need a compute node to run that simulation. For example, the second one that is make is okay. I mean, we can login nodes can be used to build the software. Okay, if in the case that the software takes, let's say, 8 hours and is like a heavy compilation, you can use the compute nodes. But if the software doesn't take long to compile, it's not yes, it's okay to use the login node. Third one is create directories. Okay, this is a bash script or shell script, and the name said that yes, create some directories or do some light stuff. This is also okay to run on the. The fourth is molecular dynamics. Yeah, it looks like it's also a simulation, and yes, it seems not to be okay. So it seems that this is like a more aim to run on a computer node. And the last one that this is to yes, this is to untar a file is okay. Also, well, when the data analysis nodes are available on Archer2, you can use these nodes to, for example, if this command will take a long time, you will be able to use these data analysis nodes. So next, do not search your login credentials. To connect to Archer2, you use a password and you use an SSH key. The SSH key has a private part that should be always in your laptop. You should not share this private key. The public key doesn't matter because the public key is to check if let's say the origin of the connection. So the public part is that's why you upload the public part to save, and actually from save is copied to Archer2. So that's fine. And the password is only for you. Please do not share the password. Sometimes, there is some monitoring on that, and the system administration team could find that there is like a password sharing, so you may receive an email regarding that. So please don't share your password and your SSH key, the private one. Also, another advice is test before scaling. Why? Because, for example, I'm working on a software and I decide, okay, I will improve, okay, the MPI communications. And to test this improvement, I decide, okay, I will run this using 100 nodes. I will use a test case of 10 hours. Imagine that for some reason there is an error and the software takes 10 hours. using 100 nodes, this is a lot of budget that you will consume, and the result will be a failure because the software that is something that is not configured, and also the same happen when you are creating a submission script. You create the submission script, but imagine that don't know, you forget to copy the test case, or you forget to do something trivial. So my advice here is please do first, for example, use a short test. Let's say imagine 10 minutes, one node, and you check two things: if the submission script is good enough, and also you check if the software is good enough. Okay, you could be unlucky, not lucky, and at the end of the execution it could fail at the last stage. But yes, my recommendation is first to do a short test. Also, an advice that just come to my mind. For example, if the software has like a different steps, imagine that this is a simulation, because I have seen actually I have seen this with a recent query. Imagine that this is a simulation that takes 14 hours, and at the end of that simulation, when you try to save the results, it fails. So you have spent 14 hours running the simulation, and at the last step it fails. Also, a recommendation is, for example, the simulation, instead of having 14 hours, you can do the simulation taking, let's say, 10 minutes or half an hour, and then do the last step, do the saving into disk, and you can check if the last step works or not. Okay, what you are saving into disk is dummy data. Doesn't is maybe it's not like useful, but you can check that it works. Okay, I remind. What's next? Okay, have a backup plan. This is very important, and actually you don't realize of how important this is until you by mistake delete some files or something is wrong with the. So for example, for code, for source code is you can use GitHub, GitLab as a version control system, has a backup. Also for large files, ideally you should keep a copy on your laptop, or in I guess that your university should offer a backup service. So please use backups, because in case that by mistake that you delete something, or imagine that could happen that you run a script or you run a software and do some write some mistakes that you cannot recover that file. Yes, it's important to have a backup. So yes, please. And also here is a mention that rsync is useful, because rsync doesn't copy everything from your folder, for instance. Just copy the files that have been modified in the last copy. So this is a very powerful tool in order to save timing transfer. And last one is the regarding transferring data. Should bear in mind that, for example, if you are using a VPN, for instance, maybe the transfer gets slowed down. Also, they mention about the metadata performance. It's not the same to transfer 1 million files that take these files together into a tar file and then transfer that file. For example, doing that, the metadata performance is much better because you only copy one file. You are not copying 1 million files. So that's why we insist that please use tools like tar and zip to create one file, and this file could contain as many files as you would like. So yes, here this explains that you could not always get the best performance because depends of the network, also the depends on where you base that you could hit some firewalls. So yeah, the advice is to use tar, for instance, to create a large file and transfer that. So well, key points to sum up: be careful how to use the login node. Also, keep backups of your data. Don't run large or large stuff in terms of computational resources. And well, I see that the person who wrote this was like insist that please don't run anything, well, like anything resource consuming on the login node, because it's like a repeat twice. Cool. So let's jump to save. Okay, I think that to see save is like easier if I go to here. I will move this out. I'm not sure if I do. Okay, you can see. Yeah, I was just checking that you can see here the menus, right? So okay, useful things about save. Here, once that you log into save, you have on the top of a menu. For example, you see a login account, and you see for example, for ARCHER2. In my case, I have this account for a past course. So this is the current account that I'm using now. Well, here there are also accounts because save is was used for Archer, now is used for ARCHER2, and also will be used for Cirrus and other EPCC machines. So that's why I'm not sure if I can make this bigger. Yes, now I think it's better. You can see that yes, the account of Cirrus, Ultra, Fulham, that this is an EPCC machine. This one that is called NextGen.io, that this is also another EPCC machine. Details about this account. Here you can see some information about the account. You can also see the user disk info. So, well, this is like a calculated that, yeah, I have 22 files. And also the resources of the project, that our project is TAO22. So the remaining budget, we have like 1,000 CUs. A CU, I remember that is the unit that is, for example, if you run a job on a node for an hour, this is a CU. And also, we have here the quota that we see that for work, we have 50 gigabytes. And also we have For home, we have 10 gigabytes. Also, I can see the public part of my SSH key, and I can, as Julien explained yesterday, we can add a new credential that is like a SSH key. We can view our password. Actually, this only works the first time because this is a one-time password, and for security reasons, you have to change that later. So you can request access to a package, request group budget. This is in case that you have you can use guest budget. Well, this button, you will not have that. This is a set login only. This is like for project managers. If you have if you are managing a project on Safe, you can tell that this is a login account and the user cannot use for example, we can see this account, for instance, that I'm not a project manager. You see that I don't have that button. And actually I have, gosh, I have 3 SSH keys. I need to tidy up this a little bit. Let's come back to the course account. Also, you have here your the user reports. Here you can, for example, you can find. Let's use this one using job report, and you can specify the time frame. Okay, you don't see them. I click here in the data and you don't see the menu. I can select the time. Also, I can select the project. In my case, this project is yes, this one. And if I click in preview, I can see the jobs that I have executed. So I see that yesterday I executed these jobs. This is in a 0 because this job failed, but if you see at the end, you see that, for example, this consume 0.003 CUs. This is like because the jobs it only took seconds, so the consumption were quite small. Also here the budget, resource, etc. So you can get access to these resources. Okay, let me check what else. Well, this is also here, if this part of the menu first, in your details, you can update your email, change the safe password. Also, you can update personal details, update email settings. Let me check. Here, or user mailing your mandatory, but for example, you can opt in or opt out, or the service status notifications, or service news, major announcements, etc. It's good to be opt in this mailing list because, for example, in case that ARCHER2 is in a maintenance session, or for example, courses that are announced, training courses that are announced on regarding ARCHER2, you can receive that information on your email, but I mean, you can update this list preference anytime. And also, useful thing here is publications. What's this? Imagine that, for instance, you use ARCHER2 to get some results, and these results are published in a paper. You can add your paper to save, and this is like also important and useful for us because as you may know, ARCHER2 is the national HPC system, and we need some justification to see, okay, this service is useful for the community. How can we demonstrate that? One of the things is saying, okay, look, or these papers have been published thanks to ARCHER2. So the point here is if you can add your publication here. First, you need to select the project. Okay, I will select this or project TIO22, but also you can select, for example, I also belong to this project, the Archer CSE service. So you should select the relevant project. View. Well, we get the message that there are no publications registered for this project yet. So for example, you can add a publication. To add the publication, we need the digital object identifier. So you paste the DOI here, and you add that to the project. Let me check. I'm not sure if that is a project. Well, for example, here this project contains these three publications. And these publications are later included in the ARCHER2 website. That should be, if we go here, let me check publications. So these publications are listed here. So also it's a way to like promote your paper. And also you should acknowledge the use of ARCHER2 in your paper in the acknowledgements. Let me check if there is some. Well, the acknowledgement is mentioned in the next lesson. Okay, so I'm not sure if I forgot something to mention about safe. Yeah, I think that's this. I will check if there are any questions. Yes, please, if you have any questions regarding safe, please let me know. Well, this is exactly this is yes, this is a very good point. How to submit a query in case that, for instance, you have an issue with your software that maybe the performance is not the best, or it's failing, or you need some guidance to talk about something. You have different ways. One way is to send an email to support@archer2.ac.uk, or you can use Safe. You can click that in the submit a new request, and the subject, okay, let's send something. Subject is like a test query. Just to because this is handled by the service desk operator, just to make his or her life easier. So project query relates to here is useful if we select the project, so software developers. Also here you can select the service, that in our case is ARCHER2, but imagine that you have an account on Cirrus, or well, Archer not anymore, but on Cirrus you can select and And the application, you can also, in case that the application is listed here, you can also select, let's say that we have an issue with CP2K. And the description of the problem, you can write this is the problem description. Yes, you can type whatever text that you find. Please kill this query as it's just an example. Explain during a course. Also, what we recommend here is give as many details as possible in order to debug the issue or to offer a better answer. Also, you can attach some files, and when you are done with that, you can send the query, and you see your query has been submitted, and to the help desk, and the tracking ID for this query is this one. If I click on that, you can see you can see your query that status pending because it's still not processed. And also your support request will be listed here. Okay, so I think that's what I wanted to talk about Save. Hello everyone, welcome back to the ARCHER2 course about the software developing on ARCHER2. The idea of this second part this afternoon is I will explain next steps. That this is like about the ARCHER2 training, the ways that you can access ARCHER2. And after that, we will have some exercises. The idea is that you can either do the exercises and learn a little bit more about ARCHER2. Also, if you have some software that you want to run, or you want to compile, or you want to test on ARCHER2, you are also free to do so. So this is like your decision. You can either run the exercises or run your own software. And both Julien and I will be around to ask you your questions, etc. Also, just to let you know that the exercises part will not be recorded. So we are just recording this chapter, next steps. After that, you will be free to do the exercises and ask as many questions as you may have. Okay, so let's start. This is just like to close a little bit, let's say, the theory that we have seen about the ARCHER2 service. We have, as I mentioned before, we have an ARCHER2 service desk that in case that you have any questions or any issues with the software, you can contact us either via email. That the email is support@archer2.ac.uk, and also you can use Save, as we have seen before lunch. About the documentation is in this link that is docs.archer2.ac.uk, and the structure is we have the user and best practice guide that we have a expansion of the contents that we have seen during these 2 days. We have a research software libraries, and also we have like other sections, like for example, known issues is when you have an issue, is good to have a look at it in case that something is listed here. Here on the right part, you can find the table of contents. Also the frequent asked questions, Kickstart guide for users, developers. So here is the documentation. Also, as you may notice, the documentation is in a GitHub page. So in case that you want to, don't know, you find a typo, you find, for example, you are working with cast you find that something that useful to add to the documentation, you can click here. Well, this will lead you to GitHub. You can type your username, password, and you can do the modification and submit a pull request. And the CSC team, the ARCHER2 CSC team, will evaluate that pull request and will accept if yeah, that's and also if the content is like good enough for everyone. So this is regarding documentation. ARCHER2 training. I recommend you to keep an eye on the ARCHER2 training page. That upcoming courses are listed here in this table. And what else is interesting here? For example, course repositories. Course repositories, you can find the course material of all previous courses here. Also, you can find webinars, for example, differences in Archer and Archer2. And you can find the recording here that is uploaded to the YouTube channel. And also you can download the slides. So this part of the website is quite interesting to keep an eye on. What else? Getting access to ARCHER2. We have also here this website that this is like ARCHER2. If you click on this top menu, support and access, you can click here in get access. And here you can find the open ARCHER2 calls that for example, we have the pump priming, that this is like in case that you want to run a small test case or you want to get some time to elaborate some speed up uploading or something like that, you can apply and you can get instant access. Well, on Archer, during Archer's service, it was called instant access, and now it's renamed to pump priming. Also, we have other projects, other project calls. Mention here the ECSE that case here. The ECSE calls that where the third call is just closed, but calls are 3 times a year. So here you need to submit a project, and the idea is we give you some ARCHER2 resources to improve some software. Here you have the whole documentation of this call. I recommend you to have a look at that. Yes, if please apply to this support call. Okay, this is mentioned here. And what I mentioned before, acknowledging ARCHER2 is include this in case that you use ARCHER2, include that you have done so because it will be beneficial for a future service to justify the need of HPC. Otherwise, it will be more difficult to justify to get funding. So yes, this is what I wanted to explain in this part. I'm not sure if did you have any questions so far about these things that I just explained? Great. Also, in case that yes, you read something and you have any questions, you will be able to ask them. Yeah, today until 4 p.m. Also, please feel free to send me an email. Also, a reminder, we have a follow-up session that this follow-up session will be half an hour where you can ask any questions that you may have. The session will take place in 2 weeks' time, if I remember right. Anyway, if not today, at the end of the session tomorrow, you will receive an email with further instructions about this follow-up session. So now I think it's time for exercises.